hey, if you're listening to this, I am so sorry. I got home on Friday and forgot to do this. And then I just haven't looked at the internet. Oh, well, that's not true. I looked at a bunch of crap on the internet all weekend, but I didn't do any schoolwork all weekend long until just now. So I just checked my email. There's like 3 people going, hey, you forgot the video. And I feel horrible. So I'm very sorry. So let me get this done real fast and I'll post it and I'll send you a message or something. Luckily, I don't know, you may have just not even tried the Delta Math because you thought it had to do with this. Luckily, the Delta Math stuff really wasn't. This wasn't necessary. This is harder than what we're going to do there, but let's just get at it. So here's all our basic exponent rules that you have learned in the past, okay? Where, when you multiply things with the same base, you add the exponents. When you take a power to a power, you multiply the exponents. If you have a product raised to a power, you can also think of it as the product of those two things raised to that power. Negative exponents, you bring in the bottom of fraction as long as your base isn't 0. Any non-zero number to the 0 power is always 1. Something like this. I actually do this. It's a to the n of the bottom. I think of it as a to the negative n of the top, and then I add my exponents, but that's why you can just subtract them. A power of a quotient is the same thing as the quotient of the two powers. You can do that. So pretty much what's going to happen is that you're going to take those basic exponent rules in this section and apply them in a tougher way. Okay. So like right here, you're multiplying two things with the same base. You keep the base, you add the powers. So when you add a fourth and a half, common denominator is a 4. So we're going to get 7 to the 3/4. Now, if nobody told you how that needed to look, that answer is just fine. Maybe they wanted you to write it as a radical. So it's the 4th root of 7 cubed, and 7 cubed is 343. So you could write it any of those ways. This is the one I would prefer, but, it didn't say to write the radical form, so it was okay to stop at 7 to the 3/4. Let's see, next one. Inside here, they're not the same base, so we can't do anything with that. But if you've got a product getting raised to a power, then that's the same thing as the product of those two individual things, that's the mathematical term for it, raised to that same power. So, and then when you raise a power to a power, you multiply the power. So half of 2 is 1. Here's a 2/3. 6 to the first is just 6. Multiplied by the cube root of a 4 squared. Okay, so that's 6 on the cube root of 16. Now, if we were going to do all this, turn it to radicals, you wouldn't stop there because 16, if I break it down to the primes, I definitely have 3 of the 2's. So I could make the cube root of 16 2 on the cube root of 2. So this is pretty much as cleaned up as you'd probably ever want to have it. There's a slightly quicker way, like right here. You could have thought of it like this. A 4 is a 2 squared. So when you square that, there's 2 to the 4th, and you can see it a little quicker that there's definitely 3 2's in there. So I can pull one out. This one, you've got 4 to the 5th times 3 to the 5th. We can't do anything there. However, since they're both to the 5th power, I could think of this as 4 times 3 all to the 5th, and then it's getting raised to the negative 1/5. So it's 12 to the 5th raised to the negative 1/5. And then when you powers to powers, you multiply the powers, and 5 times negative 1/5 is a negative 1. So we can just turn it into 1/12. Okay. This one, you've got 5 to the first, 5 times 5 to the negative 1/3. Or you could just go, I'm dividing something with the same base. I can subtract the exponents. If I did this, which I have a tendency to do, I think of it as adding the exponents. I'm just adding a negative. So it's going to be 5 to the 2/3, which is the cube root of a 5 squared. So it's the cube root of 25. This one, excuse me, you got 42 to the 1/3 all over 6 to the 1/3. Well, it helps to notice that those are both to the 1/3 power, so I could think of it like that. And then say it's all getting squared, but 42 divided by 6 is 7. And then powers to powers are multiply the powers. So a third times 2 is 2/3. So this is the cube root of a 7 squared. So it's the cube root of 49. And the same thing, here's the main principles that we're dealing with, where, and I'll be honest, in Algebra 1, you usually started here and went to there, and in Algebra 2, a lot of times it's a reverse, or actually either, so you gotta be able to do either one. But if you have a root of a product, you can make it the product of the root. So if you have a root of a quotient, you can make it the quotient of the root. So an example of that would be, okay, cube root of 12 times cube root of 18. That's the cube root of, what is 12 times 18? 120 plus 96, was that 216? And then if you just know it, I actually happen to know that the cube root of 216 is 6. Okay. If you don't know it, then you can come over here to the side. What do you have 3 of? Because it's a cube root. So you pull those out, and there's the 6. Personally, I'm a big fan of breaking the number up before you go anywhere with it, because like a 12 is a 4 times 3. And a 4 is a 2 squared. An 18 is a 9 times 2. A 9 is a 3 squared. So if I thought of it like that, I've got 3 times 3 squared. There's 3 cubed. There's times 2 cubed as part of a radicand. What do I have 3 of? A 3 and a 2. And getting the 6 that way without even having to multiply out 216. Same thing here. The 4th root of 80 over the 4th root of 5, the principal 4th roots of each, is the same thing as the principal 4th root of 85ths. And 80 divides by 5, 16 times. And the principal 4th root of 16 is just flat out 2. Okay. When people ask you to write radicals in simplest form, which is basically understood from this point forward. Like if I don't think to put it in the directions, it's there. Like you don't write radicals in any form other than simplest form once you learn what simplest form is. And so you don't want to have any nth powers under an nth root. So like, square root of 8, you don't leave square root of 8 because 8's 4 times 2, and you know the square root of 4. So you don't have a radicand with fractions. If you have a fraction, don't have a radical in your denominator. So it's kind of just getting at, what do we do with all these things? So square root of 40. 40 is a 4 times 10. So it's 2 the principal square root of 10. Or you think primes, if you don't automatically spot it, what do you have 2 of? Because it's a square root. 2, would you not? 2 to 5. This is the same thing as the principal square root of 3 over the principal square root of 25. I don't know how to clean that up other than that, but that's a 5. This one, hopefully you've seen this before. I know everybody said they did it in geometry in class on Friday. You don't leave radicals and denominators. The one number you can always multiply by in math, or just with numbers in general, not in math class, just with numbers, is you can always multiply by 1. And it doesn't change the value of the number. So a lot of what we do in mathematics when we're studying it is just figuring out what version of 1 will make it look like I want it to look. And the version of 1 that makes this look good is that one right there. Because then I get that principal square root of 9, which is just 3. Like I multiplied by the square root of 3 times the square root of 3, so I just get a 3. Let's see, 135. I don't know what that is. I could stop there because I know the cube root of 27. But there's 3 3s. Oops, bring a 3 out. That leaves the cube root of 5 left. This one, the only part that's messing up is that square root of 2 in the denominator. So we're going to multiply top bottom times that principal square root of 2. And then right here, there's a 2 times 2 more. So I get a 4 in my denominator. Right here, now we took a long time in class to figure this out. Like I wouldn't just show them what to do. So it took a little while. If you're at home learning, I'm just going to show you what to do. So if you'll break the number up, like 2 to the 3rd is an 8. So I'm going to multiply by 1 again. It's just what version of 1. Well, the version of 1 I'm going to pick is this. Because if I do, that denominator right there becomes the 5th root of a 2 to the 5th, which is just 2. And then up top, I'll have the 5th root. I've got a 7 times 2 squared, so 7 times 4. I have the 5th root of that 28. If you have 2 terms in the denominator, and one of them involves a radical, the way to get rid of that radical in the denominator is to multiply by the version of 1 that's the conjugate of that denominator. Because when you start multiplying all this out, there's 25. Here's a minus 5 root 3 plus 5 root 3. That's gone. Minus 3. And then 1 times that 5 minus root 3 is just 5 minus that root 3. And then you get that answer. So that gets that radical out of your denominator. That just says that. And this is probably the easiest part. When you're doing 1 4th root of 10 added to 7 4th root of 10, you get 8 of the 4th root of 10s. This is 2 times the 5th root of 8 plus 10 times the 5th root of 8. So I get 12 of the 5th root of 8s. And I can't clean up a 5th root of 8 because 8 is just too cubed. I don't have 5 anything. This one, they look like they're not light radicals, but if you clean this up just a little, I could bring a 3 out of that cube root and still leave a 2 under. And then I have 1 cube root of 2 there. So 3 of the cube root of 2s minus 1 of the cube root of 2s leaves 2 of the cube root of 2s. Again, sorry, that's totally should have written it down somewhere, but I didn't. So sorry this is late.